name is Kritika and I'll be sharing how I used a Python library to convert data tables extracted from PDF to Excel or CSV format. So the library I've used is Tabula and here is the documentation for the same. Tabula is a Python wrapper that converts PDF to Pandas data frame, which then can be converted to CSV file using the same Pandas library. So we first install Tabula and then we import it along with the Pandas library. This is the path to where my PDF is saved, and this is the structure of the PDF. We will use the tabular framework to read the PDF and extract tables. I just wanted to show you how tabular is useful here. Let us go back to the PDFs, and here we see there are dark cells and light cells. The dark cells are bounded and the white cells are not fully bounded. So first here we see lattice is equal to true. And what this does is it extracted 27 rows. I've observed that it is the dark cells over here that was extracted. So we changed lattice is equal to true to stream is equal to true, and now the number of rows extracted is 55. So the difference between lattice and stream is that lattice uses the cell boundaries to extract the data, and stream uses the text-based layout and alignment to find the data. So now we can move on to the exploratory data analysis of the extracted dataset. The shape of the table is 55 rows and 6 columns, excluding the heading or the header column. And then this is to check how many null values are there in the dataset, and we find that there are 0 null values. So next is we need to convert salary to float value and convert date to date time. Since here salary is a string because of the dollar symbol, and date time is also not in date time format. Um, so after conversion, we see that the start date has object type of date time and salary has an object type of float. So this is basic statistics. Employee df dot describes give you the mean, minimum, and these are all the quartile ranges. And this line is what helps convert the extracted data frame into a CSV file. And this is the path to where the CSV file is saved. So this is the Excel sheet it's saved in. You see that date and time, salary, there are 6 columns and there are 55 rows excluding the header column. So since we have successfully extracted the data into an Excel sheet, we will look at the plots and see what I've inferred. So we can use seaborn and matplotlib.pyplot for the visualization. So this is a histogram showing the age distribution of the employees. The age distribution of employees is roughly unimodal because there's only one single peak and properly above the average. So this suggests that the company predominantly employs mid-career professionals, indicating a possible emphasis on experience or stable employee retention policy. This is visualization 2, which is again a histogram. This shows the salary distribution of employees, and this is left skewed, um, which implies the peak salary is approximately $200,000. Next, this is the visualization 3, and this is employees per office. This is location versus the number of employees in that location. We find that San Francisco hosts the highest number of employees, followed by London and then New York. This concentration might suggest that these cities are like operational hubs, possibly reflecting the company's market focus. Next, we see visualization 4. This is a salary versus age scatter plot. Uh, this is a non-linear scatter relationship between age and salary. So this implies that there is no strong correlation, indicating that salary is likely driven more by role or department rather than age or seniority alone. This is the next visualization, which is a box plot, which shows salary by position. So we find that executive positions like CEO, COO, CFO, and CMO have the highest median salaries with visible outliers. This confirms that leadership roles are the highest paid. Additionally, we see that technical roles are next in line with the next range of salary. And then there is the last visualization, which shows employees joined per year as a bar plot. Here also we see that year 2011 saw the highest hiring activity, by 2013 saw the lowest. This pattern may reflect organizational expansion, funding rounds, or strategic initiatives launched in 2011, followed by stabilization or downsizing later in 2013. This is the summary of all of the visualizations, and these are the insights inferred uh, through the exploratory data analysis. Thank you.